So what we're talking about when we're talking about redesigning gateway courses or high failure rate courses, what we're talking about is changing a culture, and it takes some time. The first step is to attempt different interventions and see which ones are effective.
Based on research in physics education, we found that teaching class in a pure lecture format is not very effective on students' learning, and there is a need for students' engagement, group problem solving, discussion, and other activities for students to practice these ideas so they can apply in real problems that they're going to be solving.
If you don't get week 3, you're probably not going to have much fun in week 5. And so once a student kind of steps off or has a negative experience or gets a bad grade, it's very tough for them to catch up.
The key to our success was designing the class activity. What we did, minute to minute, we designed the class activities. Like first 10 minutes, we call it mental ramp up.
Because each individual student has their own particular gaps. And so this is where technology can be enormously helpful, because the technology can help us direct student learning to their weaknesses.
I use a lot of YouTube videos, particularly some of the ones that CSU Fullerton is currently using, as well as the Khan Academy videos that feature certain organic chemistry mechanisms.
While they're in the lab or having these discussions about the particular problems and stuff, then even so much as using a mobile device connected to the LMS and then providing them where they're doing a demo or something, providing them with the feedback right on the spot type of thing.
I find that a lot of students post their comments and that they learn from each other, and then by the time we get to class, we get right into really discussing, analyzing, evaluating, critiquing.
But of course, with a simulation, you don't have such constraints, and you have the ability to, say, simulate a population of birds on an island. So you can now take something that was very much didactic, where students were kind of told principles of, say, natural selection and evolution, and have that turn that into a more discovery-based or inquiry-based experience.
To be able to give students instant feedback and meaningful feedback on whether or not they're doing their work correctly, I think technology does a great job of being able to help them with that.
We can use some of the technology as faculty to monitor student progress. Like, for example, with clickers in a huge class, it's really hard for each student's voice to be heard.
From the Gutenberg to Zuckerberg, the technology changed a lot, and we should, as a faculty, embrace that and bring it to the classroom.
We redesign all course material. Basically, students don't need to use textbook. Everything is available online. So the performance is, after one semester, is way stronger. And last spring, we have a pass rate like over 80%. It's jumped from 50% now.
When I started teaching, I taught the way that I was taught. But changing that perspective and saying, well, taking the risk of saying, well, I have an hour, 15 minutes to teach here, and I'm not going to be blabbing that whole time. I'm going to actually, have students work and sacrifice, so to speak, some time that would have been spent, with me just talking about material. But the end result was even deeper understanding and more broad understanding as well.
The fact that we get the opportunity to talk to each other and learn from our experience and somehow share our resources, in one hand enriches our experience and knowledge so we don't have to reinvent the wheel, but also we save lots of time. The things that we always do in isolation ourselves, when somebody else has done it, and we know how to do it perhaps, but giving a syllabus that you're just going to tweak and use instead of writing it all from the scratch, it saves lots of time and improves our productivity.